Hello friends, so we have already derived two equations of motion using the graphical analysis of the velocity time graph. First v equals to u plus at, then s is equal to ut plus half at square. Now we will be deriving the third equation of motion using the same analysis of velocity time graph which we have here. Okay, so same thing, an object at t equals 0 seconds starting with initial velocity u, moving with constant acceleration a. After an time of t seconds, it has attained a final velocity v, and in that duration it has a displacement of s. Same thing here, which is depicted graphically, the velocity time graph. So here we will be using the same concept, that is displacement is the area under the velocity time graph, which we have done previously. Displacement is the area under the velocity time graph. Same thing we'll be using, but in a different way. Now in the s is equal to ut plus half at square, we divided this whole area OABC into a rectangle and triangle. Now we will consider OABC as a trapezium. Okay, as a trapezium, and the area of a trapezium is given by 1/2 into sum of the parallel sides multiplied with the perpendicular distance between the parallel sides. This is the area of trapezium. Here the parallel sides are OA and BC. For the trapezium OABC, the parallel sides are OA and BC. So here the area of the trapezium will be area of OABC will be equal to 1/2 into sum of parallel sides, which is OA plus BC. Okay. Then the perpendicular distance between them, which is equal to AD. Okay, which is equal to AD. Now here if you see, OA is nothing but CD, which is equal to U. Okay, OA is equal to U. So we'll substitute the value. OA is equal to U. Then BC is nothing but the final velocity V. OA is equal to CD, it is the initial velocity u. BC is the final velocity v. So it becomes u plus v. AD here is equal to t. Okay, AD is equal to t, the time, which is equal to OC. OC is equal to AD is the time interval, time duration. Now here is the main thing. If you remember, we have derived V is equal to U plus AT. We have already derived it. Now V minus U is equal to AT. That implies T is equal to V minus U by A. This value of T, we can use it here. Okay, T, which is equal to V minus U by A. We can use it here. That is equal to 1/2 into U plus V into V minus U by A. This. Or we can write it as 1/2 into V plus U into V minus U by A. That is equal to the displacement, the area under the velocity time graph, which is the area of the trapezium. So that is equal to S is equal to V plus U into V minus U, which is V square minus U square by 2A. This. That implies V square minus U square is equal to 2AS, which is the third equation of motion, which interrelates final velocity, initial velocity, constant acceleration and the displacement in the time interval t. So what is the difference here? Here we treated this velocity time graph as a trapezium. Okay. Formula for the area of trapezium is 1/2 into sum of parallel sides into perpendicular distance between them. Here the parallel sides are OA and BC. OA is equal to the initial velocity, BC is equal to the final velocity, AD is the time duration. Then we used the first equation of motion, V is equal to U plus AT, to get T in the form of V minus U and A in that form. Then we substituted that value of T here and we got this, S is equal to V square minus U square by 2A, and we got the third equation of motion. So here it is very important to understand the basic concepts related to, velocity, acceleration, displacement, and it is very important, the basis of this graphical method is that the area under the velocity time graph is equal to the displacement of the particle in that time duration. And we use the same concept here, simply manipulating the velocity time graph. In S is equal to ut plus half at square, we divided this whole area into two parts, first rectangle, then a triangle. So here we treated it like a trapezium. If we erase this part, it becomes a trapezium, isn't it? It is a trapezium. Okay, this trapezium O A B C. Okay, here we treat it as a trapezium and we got this result. Okay. So now we will be deriving another expression using the graphical analysis. Here is the velocity and time graph. Okay, it's the origin. Same thing, an object starting at t equals 0 seconds with initial velocity u and finally attaining a final velocity v. Okay, here. So here we are interested in deriving the displacement during the nth second. Okay, which is we have already derived using the the conventional method, which is u plus a by 2 into 2n minus 1. How we can derive it? Using the graphical method. So basically we know it is the difference between this nth second is the difference between the displacement during n seconds minus displacement during n minus 1 seconds. So here we have to pick 2 points on the time axis. Okay, so let's say this one, this is, let's say, I will take this one a little bit below. Okay, so here let's say this is any time period n minus 1, and now I have to take 1 second forward, just 1 second forward, and this will be n. This is the nth second, this one. The duration is 1 second, the gap is 1 second, 1 second gap between them. So the distance or the displacement during the nth second Sn is nothing but the area under this. Okay, so let us name the points A, B, then C, D, and let's name this as E. Okay, so here S nth, it is the area of A, B, D, C, this. Okay, so we can treat it as two separate figures. First, a rectangle ABDE plus a triangle ACE, that will do. So area of ABDE plus area of ACE. So area of ABDE is nothing but the product of the two adjacent sides, which is equal to AB into BD. AB into BD, and this will be 1/2 into base into height, which is 1/2 AE into C. AE into C. Now everything lies with this. Now here AB is nothing but the velocity, the final velocity attained at the end of n-1 second. This, it is very important to understand. This is the velocity at n-1 seconds. Okay, final velocity at n-1 seconds. Okay, this is the final velocity at n-1 seconds, that is equal to AB. This one, this thing, let me highlight it here, this Vn-1, this much, the final velocity at the end of n-1 seconds, this point. Okay, so AB is equal to Vn-1, and BD is nothing but the time gap 1 seconds. BD is equal to 1 second. Vn-1 can be calculated using this formula. V is equal to U plus AT. Here T is equal to n-1 seconds. So it will be equal to U plus A into n-1, simply substituting T with n-1. So Vn-1 is equal to U plus An-1. So area of ABDE is equal to AB into BD. AB is equal to Vn-1 into 1 seconds. Vn-1 is equal to U plus A into n-1. This is the area of ABDE. Now area of ACE, triangle ACE, which is AE into C. So here AE is equal to BD. Let me use a different color ink. Okay, AE is equal to BD. Okay, AE is equal to BD, which is equal to 1 second. Okay, same 1 second duration. AE is equal to BD. Now CE is equal to CD minus ED. Okay, CE is equal to CD minus ED. Okay, CD minus ED. Now here CD is equal to the final velocity at the end of n seconds. Here it is n seconds. Okay, this is n seconds. So this is the final velocity at the end of n seconds. Similarly, it was final velocity at the end of n-1 second. Similarly, here it is final velocity at the end of n seconds, which is Vn. Okay, Vn. which is equal to CD. ED is same as Vn minus 1. Okay, Vn minus 1, same thing. ED is equal to AB, which is equal to Vn minus 1. So here CE is equal to CD minus ED is equal to Vn minus Vn minus 1. Vn minus Vn minus 1. Okay, so here the area of the triangle ACE is equal to 1/2 into AE into CE is equal to 1/2 into 1 second into Vn minus Vn minus 1. Okay, so basically it is equal to 1/2 into Vn, which is equal to U plus An, using V is equal to U plus AT. V is equal to U plus AT. So Vn is equal to U plus An, and Vn minus 1 is equal to U plus An minus 1. Okay, so that is equal to 1/2 U plus An minus U plus An minus A. That is equal to 1/2 into U plus An minus U minus An plus A. So here U minus U got cancelled, plus An minus An get cancelled, and that is equal to A by 2. So the area of triangle ACE is equal to A by 2. Previously we got the area of the triangle, the area of the rectangle ABD as U plus An minus 1. So the final thing, okay, the final thing S nth, which is equal to the area of rectangle ABDE, okay, area of rectangle ABDE plus area of triangle ACE is equal to U plus A into n minus 1 plus A by 2. So here if we take U plus A by 2 common here, then we'll have 1 plus 2 into n minus 1. 2 into n minus 1, and that will equal to U plus A by 2 into 1 plus 2n minus 2. That will be equal to U plus A by 2 into 2n minus 1. This is the final expression, final equation. Okay, the displacement during the nth second. And always remember, this is equal to Sn minus Sn minus 1. Never get confused with Sn and Snth. Sn is the displacement during the duration, the entire duration from 0 to n seconds. Sn minus 1 is the displacement during the time interval from 0 to n minus 1 second. Snth is the displacement during that 1 second time gap between n minus 1 to n. Okay, Snth, always remember, is the displacement during that 1 second time gap between n minus 1 second and n second. Okay, because the difference between n and n minus 1 is 1 second. So this is that displacement during that 1 second time gap between n minus 1 and n. Okay, like the displacement between 2 seconds to 3 seconds. Here n is equal to 3, n minus 1 equals to 2. Like 4 second to 5 second, this 1 second gap. Here n is equal to 5, n minus 1 is equal to 4. Like 7 seconds to 8 seconds. Here n is equal to 8, n minus 1 is equal to 7. Like that. Okay. So that gap between 1 second gap between 4 to 5, from 2 to 3, from 7 to 8, during that gap, how much displacement has happened, that is Sn. Okay. Yes. So here we have derived it, u plus a by 2 into 2n minus 1. Okay.